Today we'll be learning something important. I know possibly I've taught this topic in this group. So we're looking at indices, the laws of indices. And I won't waste the time. Let's go to the laws of indices and how it is being applied. Number one, we have what we call multiplicative law of indices. Here is the example. Imagine we have a raised to the power n times a raised to the power m. You all know this. When you're multiplying numbers or variable with the same base, maybe you have 2 times 2, 2 raised to the power something times 2 raised to the power something, it can be 5 raised to the power. So since the numbers are the same or the variables are the same, so at that point, you do what? You pick one of the variable, just like fraction. In like fraction, if you have different fraction that is being operated by either plus or minus, and they have the same denominator, you pick one of the denominator. So here you pick one of these and add the powers. That's the first law. Second law, indivisibility law of indices. Imagine you have the same thing divided by a raised to the power m. This will still give us, you pick one of the base, which is a. This is a. You do n minus m. You understand? So now we have another law. Are you with me? Please follow through. So we have another law. In case you have power of power, maybe we have a raised to the power n all together raised to the power m. What do you do here? This is going to be a. Now do n times m. I will tell you where this thing is being applied. Even when you have a raised to the power 1 or 2 over 3 all together raised to the power 2, what you are actually going to be doing here, let me use a number. If we have maybe 4, what you're going to be doing here is 4 raised to the power 2 over 3 times 2, which is going to give us, or even if here is raised to the power 3, which let me say here is raised to the power 3, this cancels this. So this number will end up giving us 4 raised to the power 2. But that's by the way. So let's go back to what we are doing here. The next formula, inverse law of indices, the next law rather. So we have a raised to the power minus 1. And this is very important. This is not just, one thing about this indices is that it applies in all numbers. When you have a number or variable or anything raised to the power minus 1, that minus can be averted. You can remove that minus and this is called inverse law. Take 1, take this minus up. I will tell you something. It's not necessarily, the minus go up as 1 all over. This 1 over is centered as minus 1 over a raised to the power 1. Imagine this is raised to the power 2. This would have been minus 1 all over a raised to the power 2. You understand? I would like to use another alphabet because some people may be seeing this a as 9, or depending on the handwriting, maybe. So now, let's have, the reason why I changed this from 1 is, some people often think that it is that 1 that is going up. It's not that 1. It is this minus that is brought up as 1 all over. You understand what I'm saying? The fifth one will be having a, let's say, a raised to the power n all over m. This will be very simple. What you do is, the down number, this is a variable. It can be a number raised to power fraction. So in that fraction, the fraction is made up of the numerator and the denominator. The denominator becomes the root of that. So this is m root a all raised to power n. You understand? 1, 2, 3, 4, 5, 6. Now if we have a number, a raised to power, this is almost the same thing, 1 over n. It's just, this means n root of a. It's almost the same with this. For example, if you have a number 25 1 over 2, this is actually the square root of 25. Yes, this is the square root of 25. What it's trying to say is that this is, and all over raised to power 1 is still the same thing, so no need. And you know that this putting square root, no need of indicating that it is 2 here. So square root of 25 is 5. With this, we'll have more laws. With this, I believe you'll be able to solve every question in indices.